Hi guys, welcome back. This is Professor Hank, and in this video, we're going to continue our discussion on C++ 11 features that you might have forgotten about, or maybe just never learned about in the first place. And in this video, we're going to talk about, or learn about, or review the array container. The array container. All right, so why do I say the array container? You might be thinking, why am I going to talk about arrays? You might be thinking to yourself, arrays? What arrays? We know what arrays are. There's nothing. You don't need C++ 11 for arrays. Ah, dear viewer, but that's where you're kind of wrong a little bit. So you've got your normal primitive built-in arrays, which are basically just glorified pointers. All right, but in C++ 11, they added, well, they didn't add it. It was around in an earlier version of C++, but what they did is they moved it from one header file to another. All right, so the C++ array container is a entity, is a thing that you have to include, right? It's in its own header file array. So you have to do hashtag include array, and that allows you to create array objects, right? So there's an actual template in the standard template library where they wrapped up regular old arrays that you're used to, primitive arrays, into a class. And so by doing that, they allowed for the array to do certain things and also to be a bit safer. So what that means is you can't do any invalid memory location accessing. You can't use invalid subscripts, for example. You can't write past the end of the array. You can't write access elements that are not in the array, that sort of thing. And if you try to, then what will happen is that the array object will raise or throw an exception. So it protects your memory, and it's a bit safer, and it's actually better than normal old primitive arrays. Now you might be thinking, well, why don't you just teach this type of array, the array container? Well, you still have to understand what's going on in memory. So that's why we study primitive arrays. So that way you can get practice, understanding that, hey, this is this set of contiguous memory locations, and there's these things called elements and stuff like that. It gets you a little bit closer to the hardware, I guess you could say, and to the actual memory. And how to manage that. And so then we can teach about dynamic memory allocation and versus static memory allocation and all that stuff. All right. So what I'm going to do is I'm just going to show you the basics of how to create this thing, how to use it, how to access it. And it's actually pretty simple. I'd say the biggest benefit of this thing is the fact that you can't accidentally access invalid memory locations. You can't use invalid subscripts or array indices because it'll raise an exception. So it's safer in that way. All right, and you can actually, since it's an object, right? Since you create actual array objects when you define these things, you can ask it certain questions. Are you empty? How big are you? What's the maximum capacity that you have? Right. So the way these things work is that when you declare one of these array containers, it instantiates an array object, which is just kind of like storing inside of itself a statically allocated array. So when you create one, you have to specify the size of that array, right? Its capacity, I guess you could say, and also, what type of data it's going to hold. All right. So why don't we go ahead and create one or two of these things, and I'll just show you really quick. And we won't even be that long of a video. So let me switch us on over here to Visual Studio so you can see it. All right, so what we need to do is we have to hashtag include array. All right, so this is going to give us access to an array template. Right, it's a templatized class that, like I said, kind of encapsulates arrays and then provides some methods for interacting with them more safely. So how do you define an array? How do you create one? What does that even look like? All right, well, I'm going to show you. I'm glad that you asked. So what you have to do is you have to create an array like it was a normal data type, like int or double or whatever. But then you have to put inside a square brackets, because it's a template, a couple of things. One is the type of data that the array is going to hold, and then the other is an integer that's going to dictate how big the array is, and then you can specify a name for the array. Okay, so something like that. Right now, when you do that, okay, that's going to create an array that has an initial size of 10 elements. Okay, so we can then go in and add some values in, assign some values to it, all that kind of stuff. So you can use the array operator that you're used to, because it's been overloaded for this. Okay, and you can also use a few other methods, right? So to access the individual element, you can also use a method called at, right, which will allow you to specify a specific value, right? You can also use a method called front, called back, and what these do, these are all methods that you can use to access different elements of the array. So let me give you an example. So I can say something like r of 0 is equal to 99. Okay, I can say r of 1 is equal to 88. I can say r of 2 is equal to 77. But then I can also say r dot get 0, or maybe even 3, right, is equal to 66. Okay, or not get, sorry, at. Don't know why I said get. At. Okay, so then we can go and run a loop, and that's what, 4 elements that I did here, and we can access the individual elements. So I could do that by using the array notation that we're all familiar with. All right, and I'll go ahead and run that so you can see the results. Make sure that you can see it. Build. Oh, it'd be useful if I actually put a pause there so you can actually see the output, right? So I'll just do our friend cn.get there, and we'll try it again. So there you go, right? So you can see there's the values. Okay. Another thing we can do is we can use range-based for loops with this thing. So, something like this, and then we could print out the contents of it. Oops, I need to do that. I'm using a range-based for loop. Okay, and so then we'll see what we see. So you can see 99 there, 88, 77, 66, and then a bunch of garbage. Where'd all that garbage come from? Well, those are the uninitialized elements in the array, right? So the range-based for loop will iterate over all of the elements of our array, okay? And so I didn't assign values to a certain number of them, all right? So let me show you some other stuff here. Let's put a new line character in there. So you can also access the first element by doing something like this, r dot front is what I'm looking for, and also back. So r dot front, right? And then you'll see that that front value gets displayed again. So 99. Okay. Let me make sure you can see that whole thing there. Oops. Right, so there's the 99, and then there's the 99. Okay, now I could also do cout r dot back. That's going to show me garbage again, right? Because I didn't put anything in the last element. So you can see there's the garbage there. But I can, oops, let me close that. I can also use those methods to assign values to the array, just like I did with at. Right? So there's a lot of little convenience methods that you get that you wouldn't get with a normal primitive array. Right? So cout, let's see here. Oops, not cout. I want to say r.back, and we'll assign that 4. Okay. So now I'll run the range-based for loop again. Oops. And we'll see the results of that. Okay. We should see the last element's no longer garbage. Oops. Go ahead and compile. Right, see, so there's the 4 there. So again, you got some convenience methods here that you normally don't, or that you don't get with primitive arrays. How about we do the size method? So r.size. And you Java people, you might be looking at this going, oh yeah, it's an array list. Yeah, right? Or close to it, I guess you could say. So there's the size, right? That's how many elements that it has. And it probably should be like this. All right. To put a little bit of space in between. So let's go through some more methods here. We did back. Size. We can ask if the thing is empty. So we can say something like this. We can say cout r.empty. Okay, and then that'll tell you true or false based on whether or not there's values in the array. So 0 is false, remember that, so it's not empty. You know, if you don't believe me, you're like, what do you mean it's 0's false, right? Well, look, r.empty. Oops, I don't know why I keep putting ENDL on the end of things, and I probably should name this, huh? Okay, so there we go. Now if I was to cout B, we'll see, it's going to do the same thing. Right, so there's that 0 again. Okay, now you might be thinking, well, empty, what do you mean empty? Well, we have a member function that is, or allows you to be able to tell if the array is empty or not. Okay, so, well, how could it ever be empty? Well, the array object will allow you to create arrays that have 0 elements, which is kind of weird. Okay, so I can name this. So now, if I was to do b equals, oops, I already named a b, didn't I? If I was to do, we'll name this r2. Okay, so now if I was to say r2.empty, and then cout my b, okay, then we'll see that it's going to be a 1 for true, right? So you can make those things, like I said, you can make them so where the size is 0, okay, which is kind of weird, but you can do it. Now, another thing you can do is you can get the memory address from the object and then do something with it. Okay, so what do I mean by that? Well, what if we create an array of characters? Okay, and we have, I don't know, 5 elements in there. Okay, and we'll go ahead and initialize it with with a bunch of characters. A, B, C, D, E, right? So now what I can do is I can, because what this is a fixed size. This is going to create a fixed size array of 5 characters that's being stored in the object. All right, and so I can ask it for that memory address for that thing. So I could do something like, I don't know, cout r.data. Okay. Now when I do that, oh, I used the same name here, didn't I? So let's do a different name here. Reuse the name. So now you can see that there's the A, B, C, D, E. Okay. Now the problem is, where'd all these the rest of those garbage characters come from? I didn't put a null terminator in there, did I? Right. So let's do that now. So now let's try it again. See, it basically becomes a C string in that case. So you can do all kinds of cool stuff with that, because you get access to the memory location of the array that the object is keeping track of. All right. So let's see if there's anything else here that I want to show you. Yeah, so another thing we can do is we can ask what the maximum size of the array is. In other words, what is its capacity, right? So we could say something like r3 dot max size. Okay. So then if we run that, right, so that's going to be 6 because, well, there's 6 elements in there. Okay, cool. Now, what would happen if I tried to access, what if I tried to use an invalid subscript? Okay, and do something like that. What's going to happen? All right. See how can you see that? Let's make sure that you can. Oh, you can't see it because it won't show up on here. But what it did is it threw a exception, okay? And the exception is array subscript out of range, all right? So we'll go ahead and abort. So that prevented me from assigning this J to a location that isn't valid, right? That doesn't exist. You can't have, there's no negative subscripts for arrays in C++. You can have negative subscripts in other languages like Python, but not in C++. All right. Okay. So, I mean, that, if nothing else, that's probably one of the best features, is that your memory's safe. You're not going to be able to put things in weird places. You're only going to be allowed to assign values to arrays that actually have elements to have the values assigned to, right? If you only have 6 elements, you're not going to be able to assign a value to index 13, for example. It's just not possible. All right, so let me show you a couple of things you can do with this. You can create arrays by using, we'll make this R4, by using initialization lists, like we saw in earlier C++ video, right? Using these different types of initialization lists. Okay. And then this is R4, right? Cout, I call it I, right? Okay, yeah. So you can use an initialization list. Oh, my crashing because I still have the R3 on line 49 there, right? Okay, so let's get that in there. My exception got raised, but now you can see there's the 1, 2, 3, 4, 5. So you can use initialization lists with these things. You can also use the fill method. So I can use something like this, or dot fill, and then I can pass to it an integer, and that will go through and fill the entire array with the argument value. Okay, so then you're going to see it changed all 9s there, right? So I mean, there's just all these little bookkeeping or quality of life, I should say, features that you can use. So, and there's some others too. I think the video's probably gone long enough here. I mean, there's you know, well, I'll do one more. I'll do one more. Okay. So, let's see. So I got R4 up here, and I'll create one more array. This is also cool too. Okay. And I'd be remiss if I didn't show it to you. Let's see. So we'll create array int. I'll make it 5 elements also. We'll call this R5, and I'll go ahead and fill it with all 8s. Okay. Now what we can do is we can use relational operators with our array objects. Okay, so those methods have been overloaded as well. And so the array R4 here is going to be less than R5 if it's lexicographically less than. Okay, so what that means is it's just going to go element by element, comparing each element, and you know, making its decision based off of that. And I have other videos where if you want to see an example of how lexicographical comparison works, you can check it out. But the point is that you can now compare the contents of your arrays, well, the array and the array object anyway, against each other using these operators. In the past, if you just had a primitive old array, you weren't comparing the contents of the array objects. What you were comparing was the contents of the array pointer, right? Of the memory location or of the memory address of the first byte of each array. That's actually what's getting compared. Okay, so we could say R4 is less, you know, something like that. Else, let's see out, R5 is less. You know, and you know, it just gives you a base way of comparing them, right? So here R5 is less. Why? Because remember, in R5 I put all 8s in the array, whereas in R4 I filled it with all 9s. All right, so that's cool. I mean, you can also check for quality. Basically, you're just seeing if the contents are the same or different in lexicographical ways. All right, let's see here. Yeah, I think that is going to be everything that I'm going to show you. I mean, there's some things here too with iterators. I haven't done any videos on iterators before, so I won't show you anything on that in this video. And also, there's a neat little swap function that I'll leave for you to discover as an exercise. But yeah, I mean, the arrays, they're cool. They're a lot safer than using primitive arrays. The thing is, though, is that they can be slower. Their performance can be slower in certain respects. You know, doing swaps, for example, are a bit slower using that function because it does an element by element swap, and then also the comparison can be a little bit slower because it does an element by element comparison. So we're talking big O of n here, but other than that, though, I mean, in terms of practical application, practical usage, you know, if performance isn't an absolute critical factor or requirement for whatever you're building, then these can be a much safer alternative to keep you from accidentally stabbing yourself in the face when you use the wrong index or subscript. And they give you some built-in functionality. And of course, you can always extend that functionality if you want to change the way the relational operators work, for example, or if you want to add some additional functionality, then you can always, use that as the base class and then extend it, make a more specialized version. Okay, well, that's everything that I have for you in this video. We'll continue the series next time, where we're talking about C++ 11 features that you may or may not have learned or that you might have forgotten about. And if you thought the video was useful, if you learned something, appreciate it, the work, feel free to give it a thumbs up. If you thought the video sucked, it was a complete waste of your time, feel free to give it a thumbs down. I'd appreciate a subscribe if you're so inclined. Also, we have other ways of supporting the channel. If you leave a comment, we have memberships. There's links down there for donating, whatever you want to do, or nothing at all. It's completely up to you. All right. Well, thanks for watching, and we will see you next time.